Hello everyone. This video will show how to write equations of trigonometric function in its transformed form. Please remember that the transformed form of trigonometric function comes in a form of this. So let's go ahead and go over this example. So in this example, we're given the amplitude of 5, a frequency of 2, and a shift to the left of 3 units and a shift going up of 1 unit. And we're supposed to write a sine function that would represent all this given right here. So I'm going to go ahead and write the given on the side here. So we start with our amplitude, which is 5. We are also given the frequency of 2. And this shift to the left represents C. So we can go ahead and write C is equal to -3. The reason why this is negative because it was shifted to the left. And then we also have a shift going up, which is 1. So that represents our parameter D, which is a +1 because it went up. Now, please remember that the formula to find for period is... So this is the formula for period. We're going to need this to find for B. Now, if you notice, we already have most of the parameters that we need. We have A, we already have C, we already have D. So we are missing B, and we're going to use period to find the B. However, in this problem, we are given frequency. Now, please remember that frequency and period are inversely proportional to each other, so that we can go ahead and write the formula for frequency to be 1 over period. So what we do right now is we will plug in the value for period, which is 2 pi over b to the p here. So our equation would come out. So this is an example of a complex fraction. So the numerator is 1. What we do is we're going to flip the denominator and we multiply them across. So the b is going to go on top. The 2 pi is going to go on the denominator. So that we can go ahead and say that the formula for frequency is b over 2 pi. Since we are looking for the b here, we can rearrange this equation to solve for b or to have b by itself. So I'm going to go ahead and rewrite this equation up here. Please remember that the f here, or frequency, has an invisible denominator of 1, so that we can go ahead and cross multiply these two. And so we already have 1 times b is b, and that is equal to frequency times 2 pi. So this is the formula for B when we are given the frequency. So let's go ahead and plug in the value for frequency so that we can solve for B. So we already have a B value of 4 pi. So that from here, we can go ahead and write the equation already because we already have all the parameters needed. So we're going to go ahead and write f of x equals A, which our A value is 5. And then this is a sine function. And then we have a B of 4 pi. And then we have a x minus the C, which is -3. And then we have a D of 1. We can go ahead and simplify this further. This negative and a negative makes it a positive. And so our final equation would look like this. Now let's have another example. In this example, we're supposed to come up with a cosine function of this form. We're given the amplitude of 3, frequency of 5, a phase shift of 2 to the right, and a shift of 4 units going downward. So I'm going to go ahead and write the given variables down here. Please notice that our C value here is positive because it was shifted to the right. And our parameter D is -4 because it was shifted downward. Now looking at this, we already have the variable A, C, and D. We're missing the B. We can solve for B given the frequency. The formula for B again is frequency times 2 pi. So I'm going to go ahead and plug in the value for 5 here to solve for B. So our B value is 10 pi. So we can go ahead and write the equation on the side right here. So we're going to start with f of x. Our A is 3. And this is a cosine function. And then we have our b is 10 pi. And then we have a c of 2. So that's a minus 2. And then we have a d of minus 4. So this is the equation for this given problem that we have up here. So that is how we write equations of trigonometric functions in transformed form.